Good day, my wonderful celebrity nation. This week we are treating Lecture 7, Physics 102, Electric Field Intensity. Remember in our class, the previous classes we've discussed about charge, we've discussed about properties of charge, we've discussed about production of charge, we've discussed Coulomb's law, how to calculate Coulomb's law, we've discussed a lot on Physics 102, that's electricity and magnetism. But today we are discussing specifically electric field intensity. Now, before you go through electric field intensity, you ask yourself, what is electric field? So you can check our last or the previous lecture to have a full lecture on electric field. But today we are discussing electric field intensity. So tighten your seatbelt. Let's do what we know how to do best. Thank you. Now let's start with your lecture objective. By the end of this lecture, what I want you to know is one, how to define electric field intensity. Full explanation and description. You should be able to give me that. Two, you will know the unit of electric field intensity and how to calculate electric field intensity. You should know this very well. Now, previous lecture revision. Let's look at it. Our previous lecture is on electric field. And we said that electric field is that particular region in which a charge has its force influencing other charges. And I used an example. I said, if you have a charge called Dr. UD Jesus, the field of Dr. UD Jesus is the region within which other charges around can feel the force. That is called electric field. Now, properties of lines of force. Remember, in our previous class, we treated this very well. So you can also visit that lecture for proper lecture. This is just a revision. In properties of lines of force, we said that lines of force originate from positive charges and terminates at negative charges. So it acts as if the positive charge is the source, while the negative charge is the sink. So in terms of diagram or pattern, it must start from the positive charge outwardly, while it goes to the negative charge inwardly. That brought us to electric field pattern. In electric field pattern, we made it that the positive charge is the generator or the producer, while the negative charge is the receiver. So if you have two positive charges, they will repel each other, so they will never meet. And if you have two negative charges, the same thing will happen. But if you have a positive charge and a negative charge, then the positive will certainly produce and the negative will receive. So you have a continuous connectivity between the positive and the negative. Another major property of lines of force is that lines of force cannot intersect or cross each other. That is another one, most especially schools always throw it in as exam questions. Now let's look at, in that previous class, we also touched electric field intensity a little bit. Then we did some calculations there. Now let's look at today's lecture in detail. It will be a very short one, straightforward to the point, and it will give you exactly what you want. Electric field intensity. By definition, we say this is the magnitude or strength of electric field. It is the ratio of the electric force per unit charge. What does that mean? It simply means that electric field intensity is force per unit charge. In mathematics, we said that is force per, I told you, means division. Mathematically, it means division. So when you say distance per time. It means distance over time. When you say force per unit charge, that means force divided by charge. So, when you say electric field intensity, mathematically is defined as the ratio of electric force per unit charge. That means that E is equal to F over Q. You understand it to that point. Now let's look at Coulomb's law, which we treated previously. Coulomb's law says that the electrostatic force F is equal to KQQ all over r squared. Small letter q, capital letter Q all over r squared. Another book can say Q1, Q2 all over r squared. You're free to use the symbol that is very obvious or easier for you. Now, if you look at that, we have it that electrostatic force is equal to K QQ all over r squared. That is Coulomb's law or electrostatic equation. And we'll just say that E is equal to F over Q. That means that E is equal to, I'm replacing my F with the equation, which is KQQ over r squared. Then multiply by the Q that is at the denominator, we have 1 over Q. So 1 Q will go with 1 Q there. We are left with E equal to KQ over r squared. E equal to KQ over r squared. And this is another equation of electric field intensity. Now take these two equations very important. E equal to F over Q is examinable. Also, E equal to KQ all over r squared. Now, electric field intensity, you may ask whether it's a vector quantity or a scalar quantity. It is a vector quantity, and it describes the force exerted on a unit positive charge at a given point in space due to an electric field. So they may ask you whether it's a scalar or a vector. It is a vector quantity. It's not like charge. Charge is a scalar quantity, but electric field intensity is a vector quantity. And the unit of electric field intensity is Newton per coulomb. How is it Newton per coulomb? Remember that from the mathematical definition, E equal to F over Q, F, which is force, is measured in Newton. Q, which is charge, is measured in coulomb. And we'll say that electric field intensity or electric field strength is force per unit charge. That means in terms of units, we'll have Newton per coulomb. And that is how we got the unit of electric field intensity as Newton per coulomb. Let's look at the brief calculation we have here. Question number 1 says, the magnitude of electric field at a distance of 1 meter from a point charge is 10 Newton per coulomb. What is the magnitude of the charge? Whenever you see this word magnitude, be very careful with it, because sometimes there are certain questions that may carry negative and positive signs, and it's just asking you for magnitude. And maybe when you finish solving, you're having your answer as maybe 3. And you said, oh no, 3 cannot be the answer. I got -3. Whenever they ask of magnitude, they are simply asking about the size, not the sign that is attached to it. So this one says, the magnitude of electric field at a distance of 1 meter from a point charge is 10 Newton coulomb. What is the magnitude of the charge? Now let's look at the solution. The solution here, I said, remember or recall the last equation of electric field intensity that I gave to you. You remember this equation here, E equal to KQ over r squared, that we derive from the mathematical definition, E equal to F over Q. Now, when you set in that equation, E equal to KQ over R squared, what do? We now try to make Q the subject of the formula. If we make Q the subject of the formula, it will give us ER squared all over Q by dividing both equations with Q, so that we will now have Q to be equal to ER squared over Q. Now, if we substitute the given values, that means R now is taken as 1 meter and E is taken as 10 Newton per coulomb. So what we'll have is 10 Newton per coulomb, that is E, times 1 square, that is R square, all over K, where K is 9 times 10 raised to the power 9. And that will give you 1.11 times 10 raised to the power minus 9 coulombs. We found the value of charge that we are looking for. Now we'll look at question number 2. Question number 2 says, calculate the electric field intensity at a point 10 meters away from a point charge of 2 coulombs in air. I repeat the question. Calculate the electric field intensity at a point 10 meters away from a point charge of 2 coulombs in air. Then solution. You recall the same equation, E equal to KQ over R squared. We have our value of Q as 9 times 10 raised to the power 9 Newton meter squared per coulomb squared. So our charge is 2 coulombs, while the distance is 10 meters as given in the question. Now the electric field intensity will be 1.8 times 10 raised to the power 8 Newton per coulomb. How? Substitute the value of Q at where you have Q, substitute the value of R where you have R square, and now the value of K where you have your K. Every other thing there is mathematics. Try and do that now. Bring out your paper, make that solution yourself, and try to get 1.8 times 10 raised to the power 8 Newton per coulomb. Now we'll look at this before I guide you. This one says 2 charges, Q1 equal to 2 times 10 raised to the power minus 7, and Q2 equal to minus 2 times 10 raised to the power minus 7, are separated by a distance of 0.15 meters. The question says, calculate the electric field intensity at the midpoint between the 2 charges. Solution. We are looking for the electric field intensity at the midpoint. Now the question is, what is the electric field intensity? The total electric field intensity here is E equal to the electric field intensity due to charge 1 and the electric field intensity due to charge 2. That is why we'll say that E is equal to E1 plus E2. Now recall, E is equal to KQ over R squared. That's the formula we derived. So first, let's get the electric field intensity due to Q1. It is given as E1 equal to KQ1 all over R over 2 all squared. Somebody may say, why R over 2? It is R over 2 because we are looking for the electric field at the midpoint. That means the distance given now divided by 2 at the midpoint. At the midpoint. When you say midpoint, you mean half at the center point or at the midpoint of what you're looking for. If your full range is 4, the midpoint of 4 is 2. That means it's 4 over 2. That's what we are talking about. So E1 is equal to KQ1 R over 2 all squared. While the electric field due to Q2 is E2 equal to KQ2 R over 2 all squared. Somebody may say, why didn't we have R1 over 2? Then on the second one, we'll have R2 over 2. No, why? Because the distance between them, their midpoint is the same thing. Somebody is standing at the point 1 and the other person is standing at the point 4, and they are to meet at the point at the end of 2. That means the distance covered by this person is the distance covered by this person. You can try it. You can express it as practice. Check the 4 walls of your room where you are taking this lecture. Then pick 2 sides of the wall. Now, if someone is coming from this wall and another person is coming from this wall and they are expected to meet at the midpoint, that means that the distance covered by each of them is the same. That's why we'll have R over 2 rather than having R1 over 2 and R2 over 2. So note that the magnitude of both fields will be the same. Yes. Why would they be the same? Because the magnitude of the charges are the same. What is different is the sign, but the magnitude is 2 times 10 raised to power minus 7. Both of them are the same, but the sign is the different. We said, but the direction will be opposite. Yes, because one is positive and the other one is negative. So since they are in opposite direction, the net electric field will be E1 minus E2 equal to 0. What does that mean? Remember that the total electric field intensity we have is E equal to E1 plus E2. But now our E2 is carrying a negative sign, which is a negative charge. Our E2 is carrying a negative charge. So after solving both, what you will get is plus a particular value minus a particular value. That same value. For example, if E1 gives you 2, E2 will also give you minus 2. So if you substitute it in this equation, what you have is E equal to plus 2 plus minus 2. So which will give you 2 minus 2, which is equal to what? 0. This question is good to come out in your exam. So try and look at it critically, because I would like your school to try you in this particular question in your examination. Because it's very simple, either in your examination or your assessment test. It's very simple to understand and is something you can easily walk over. Now let's look at a lecture review here. We talked about definition of electric field intensity. I know you've gotten that. Any day, anytime. This is the strength or the magnitude of electric field, which is the ratio of the force or electrostatic force per unit charge. Always present it this way to the examiner. Make them understand that it's the strength of the electric field or the magnitude of the electric field. And also attach the mathematical definition, which is the ratio of force to the charge or the electrostatic force per unit charge. Then we talk about unit of electric field intensity. As you said, force per unit charge. Force is measured in Newton. Per charge is measured in coulomb. That is Newton per coulomb. That is the unit of electric field intensity. Then as for the calculation of electric field intensity, you've seen the ones we did. And that is the way to carry out the calculation anytime, any day. If you are still finding a problem in any of them, kindly drop your question at the comment section and we'll attend to it within 24 hours. So try and do that. Thank you very much for listening and taking this wonderful lecture, though short but very powerful and impacting. Our next lecture will be on motion of a charged particle in electric field. This is something different, and I will really want every one of you to participate when this lecture will come up. It's something quite different. It's not like the regular thing that every other person can, that we are handling. So try and make out time for that lecture. Before you exit, don't hesitate to hit the subscribe button. Share this lecture with your friends and try as possible as you can So comment your thoughts as feedback. Thank you and have a wonderful time. See you in our next lecture. Bye.